The Keck Observatory Archive, COA, is a NASA-funded collaboration between NEXI, the NASA Exoplanet Science Institute at Caltech, and the W.M. Keck Observatory in Hawaii. COA curates nearly all of the raw data since the observatory began operations. This presentation will provide some background information on COA and the types of data and services we provide to the astronomical community. The W.M. Keck Observatory operates and manages twin 10-meter telescopes situated near the summit of Mauna Kea on the Big Island of Hawaii. At an elevation of nearly 14,000 feet, this site provides some of the best atmospheric conditions for astronomy and is also home to many other telescopes. The Keck telescopes are among the largest optical telescopes in the world, and when coupled with state-of-the-art instrumentation, allow ground-based access to extremely faint objects. The instrumentation on the Keck telescopes is quite varied and should suit the needs of most observers and archive users. 4 of the optical instruments, DEIMOS, ESI, HIRES, and LRIS, are capable of single-object spectroscopy. DEIMOS and LRIS are also able to perform multi-object spectroscopy through the use of image masks. HIRES is commonly used for radial velocity measurements of exoplanet host stars and is the only optical instrument that does not obtain wide-field images. KCWI is the newest optical instrument and is unique among them in that it is an integral field spectrograph, and every pixel in the field of view produces a spectrum. Similar to the optical instruments, the near-infrared instruments MOSFIRE, NIRES, and NIRSPEC can obtain single-object spectra and images. MOSFIRE is the only one of these capable of multi-object spectroscopy. NIRSPEC, along with the other near-infrared instruments NERC-2 and OSIRIS, can be used behind the adaptive optics systems on their respective telescopes. Although NERC-2 is capable of obtaining spectra, its primary use is for high spatial resolution images. Like KCWI, OSIRIS is an integral field spectrograph, though with adaptive optics images in the near-infrared. Starting in August 2019, COA has been archiving data from the Keck 2 telemetry recording system, which monitors the activity of the adaptive optics system on that telescope. These data can be used to reconstruct the theoretical point spread function for NERC-2 data, allowing users to perform higher precision astrometry and photometry. Finally, COA contains data from 3 retired instruments: LWS, NERC, and the Keck interferometer. LWS is the only Keck instrument that obtained data well beyond 5 microns. As the name implies, NERC was the first generation of the near-infrared camera used to obtain high-resolution images. The Keck interferometer combined the light from the 2 telescopes to provide visibility and nulling data. COA provides science products only for the Keck interferometer. COA ingests and curates the raw data for all of the active and retired instruments on the Keck telescopes. Although COA did not start actively archiving data until 2004, data in the archive date back to 10 years prior, shortly after the start of the first science observations on Keck 1. At the end of each night, the data are processed at the observatory and are prepared for ingesting and archiving at NEXI. In most situations, the observers can download their data from COA within 10 to 24 hours after the end of their observing night. Principal investigators have exclusive access to their data for 18 months, but this can be modified at the request of the PI and with approval of the time-granting institution. In addition to the raw data that are automatically ingested each morning, COA hosts science-quality reduced products contributed by observing PIs and archive users. Recent additions to our set of contributed data include spectroscopic observations of Europa and the third data release for the Kodiak project. This data release contains flux-calibrated spectra of quasars taken with the ESI instrument. If you are interested in contributing reduced Keck data for hosting at KOA, we encourage you to consult the guidelines for contributed data on our website and contact us with any questions. The Keck telescopes have observed objects in our own solar system, high redshift quasars, and nearly everything in between. Often, new reduction techniques applied on these older data can reveal valuable new information that was previously not possible. KOA does not have information on the types of objects that are observed because such information could be misleading. For example, an observer may be targeting a specific star in an image, but that image may contain a galaxy that is important for someone else. Searching the archive using a list of objects of a known type, like exoplanet host stars, is the best method for determining which of them have been observed with the Keck telescopes. KOA has several services to help you search our archives and find your data of interest. First and foremost, our web-based user interface allows you to search on parameters such as date, position, instrument, and program information, to name just a few. While performing these searches, you can choose to also return calibration files, such as darks, flats, and bias frames, that would be appropriate for reducing the raw data. Objects in our solar system move rapidly across the sky, making positional searches for them problematic. To help with the discovery of moving object data in the archive, KOA has a moving object service that uses JPL's Horizon system to generate an ephemeris, which is then searched against the positions of observations in KOA. If your object is relatively new and is not yet in JPL Horizons, the service also allows you to enter the orbital elements for that object. In 2021, a major driver for KOA will be the completion of full data access to the archive through our new programmatic interface called PyKOA. PyKOA is a Python-based package available through PyPy and is underpinned by Nexi Tap, a Nexi Python-based server that implements the International Virtual Observatory Alliance Table Access Protocol. PyKOA provides many convenient functions that allow queries by date, object name, and position. In addition, users can enter more complex queries in the IVOA astronomical data query language. Currently, only sidereal object searches of high-res and DEIMOS observations are available through PyKOA. But throughout 2021, we will be adding support for the rest of the instruments, adding the ability to query for solar system objects, and providing access to calibrated data. By the end of the year, PyKOA will replicate, and in some cases exceed, the searching functionality on our web-based interface. Documentation for PyKOA on the KOA website includes a Jupyter notebook with many examples of the supported query methods. New users looking for a quick way to get started with PyKOA are encouraged to download this notebook. KOA provides downloadable text tables of the public data for each instrument. Users with thousands of positions they want to check against the archive may find offline searches with these tables more efficient than uploading their list to the web-based interface. In the future, our Python interface to our holdings should largely eliminate the need for these files. For certain types of quick-look reduced products, KOA provides tools to help visualize the data. These include the ability to examine high-res one-dimensional spectra, flat-fielded NERC2 images, and three-dimensional cubes from OSIRIS. In addition to the data obtained by the Keck instruments, KOA also gathers weather data relevant for the observatories. These are available to download or browse on a night-by-night basis. The NASA Exoplanet Science Institute has created a service that reduces Keck high-res data directly from the Keck Observatory Archive and produces high-precision radial velocities for high-res data taken with a specific set of instrument and observing parameters. In addition to processing new data, users of the service have access to approximately 60,000 radial velocities computed from compatible high-res data going back to August 2004. Because this service is adapted from the pipeline used by the California Planet Search team, users can expect nearly identical results to CPS. In fact, 82% of the computed radial velocities are within 1 sigma of the CPS results. Please note that a COA account is required to run this service, and interested users are encouraged to check out the NextEye website for more information. The WM Keck Observatory, in collaboration with COA, has started a data services initiative that will focus on the management of data from the preparation of the observations to their ingestion into the archive. This initiative will allow for the real-time ingestion of data so that observers will have immediate access to their data through COA. Furthermore, both observers and archive users will benefit from improvements in the metadata, which will better track the intended use of the observations. For example, sky frames can be distinguished from science frames, data within a dither pattern can be flagged, and the exact files needed for proper calibration will be identified. With this information, data reduction pipelines producing science-quality data will be possible. Currently, COA only performs simple data reductions for some instruments. These are not intended for science and should only be used for assessing the quality of the data. A multi-institutional group is now designing and writing software to be used to create science-quality data from automated pipelines. These data will be served through the archive along with the raw data. Ultimately, DSI and the subsequent pipelines will increase the scientific productivity of the observatory and the usability of the data. Stay tuned for more information. Thank you for watching this video discussing what the Keck Observatory Archive offers and how it can help with your science. We invite you to look at our site and encourage you to write to us if you have any questions.